So, okay, today we're going to take a look at section 4.3, and to start, we've got problem number 10. Given a diagram that looks a little like this, and it says that in the following figure, NO, line segment NO, is congruent to line segment PO, line segment MS is congruent to line segment RQ, and angle OSR is congruent with angle ORS. And again, this is what we are given. So we'll take a note of that. Say given. And remember, we're looking to show, let's see here, we're looking to show that triangle MNR is congruent with triangle QPS. Okay. Well, first things first, I think we should take a look and mark out our congruencies. We have NO is congruent to PO, MS is congruent to RQ, and then we have angle OSR is congruent to ORS. Okay, well, I have an idea how we're going to show this, so go ahead and we'll write out proof here. Let everybody know that this is where our proof is starting. And take a look here. These two angles are congruent. So angle OSR is congruent to angle ORS. We were given that. Well, this means that triangle OSR is isosceles. Woo. Make that legible. It's isosceles. And let's see here, the relevant theorem for that is, relevant theorem is theorem 4.7. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. Theorem 4.7. And that's exactly what we want. Then, actually, we can just go ahead and we can get rid of this. And just erase this. Looking at how the theorem is stated, because of how the theorem is stated, it says, hey, if you have the angles congruent, then the sides are congruent as well. That means that OS, that line segment, is congruent with OR, that line segment. Okay, so we'll switch colors here to mark out the congruencies that we're finding. Alright. So now take a look at this. I have congruent, 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 congruent. Line NR is congruent with line SP. Those two line segments are congruent via, we'll say, addition. Alright, now we're getting somewhere. Take a look at this, line segment SR. What I'm looking at here is that I've got this congruent, NRM, congruent to PSQ. So I've got two angles congruent. I'm going to get the two sides that border that angle congruent as well. So I'm just going to go ahead and I'm going to say SR is congruent to SR via the reflexive property, which means that, let's see here, MR is congruent to SQ, again by addition. Okay, and if I have that congruent, then that gives me this line, MR, congruent to QS. I have this line, NR, congruent to PS. I have this angle, NRM, congruent to PSQ. So, a little bit of color here. I've got from here to here to here, including this angle, congruent to from here to here and that angle. That gives me SAS. That's very important. So we'll just continue on in our proof here, and that would be triangle, let's see here, MNR is congruent to triangle QPS. And this is side angle side congruence. Okay. How did I know to use side angle side? I was given two pairs of congruent line segments and a congruent angle. It seemed like the logical choice to try and get the full sides congruent and use that interior angle. So from here I want to take a look at another problem. Okay, I want to take a look at number 13 from the same section, 4.3. Number 13, we're given triangle ABCD with the line BD drawn in. BD is an altitude of the triangle ABCD, or excuse me, ABC. So that means it's perpendicular. Perpendicular. And it's also the bisector of angle B. So BD is an altitude. And BD bisects angle B. And now we have to show, it is a W, I swear. Now we have to show that BD is the perpendicular bisector of AC. BC is the perpendicular bisector of line AC. Excuse me, BD is the perpendicular bisector of AC. Alright, let's get our proof on. Okay, I'm going to draw in what we're given here. We know that this angle is congruent to that angle. And we know that BD is perpendicular to AC. So, I'm going to go ahead and I'm going to write angle ABD is congruent to angle CBD. That's given to us. And we're going to say BD, that line segment, is perpendicular to AC. That's again given. So that means that angle BDA is congruent to the angle BDC. And this is by the perpendicular. The fact that it's perpendicular, all, I don't know, right angles congruent. That works. And then finally, I'm going to go ahead and I'm going to say that BD, the line segment, is congruent with itself. Reflexive. Okay, so what? Big deal? Well, now we have three things congruent. That means that triangle BDA, go ahead and guess the theorem, is congruent to triangle, let's see here, BDC, have to have the parts in the correct order, by angle, side, angle. Yeah, take a look. First, I said I have this angle, this side, and this angle congruent to this angle, the same side, and then this angle. That's enough for ASA congruence. Okay. So we've got these two guys congruent by ASA. Big whoop. How's that get us perpendicular bisector? Well, perpendicular bisector means that 2 points are on the perpendicular bisector of a line segment if and only if they're equidistant from the endpoints. So that means we need to show, we want to show, this is a good thing to mark, to write down what you want to get you. We need perpendicular bisector. To get there, we want to show that AB is congruent to CB and AD is congruent to CD. And that way these 2 points, point B, D, will be equidistant. Each point will be equidistant from A and C, which implies perpendicular bisector. And then that'll get us that. How are we going to do it? Well, we have the two triangles congruent. So we're going to get these segments congruent via corresponding parts. Line segment AB is congruent with line segment CB by corresponding parts of congruent triangles are congruent. Likewise, line segment AD is congruent with line segment CD, again by corresponding parts. From that we know B is equidistant from A and C, and that's by this guy. And we know that D likewise is equidistant from A and C, and that's from this guy. So then finally we're going to invoke the theorem, perpendicular bisector theorem, theorem 4.10. BD is the perpendicular bisector of AC, and that's theorem 4.10. Okay.